Welcome to this workshop skills video, how to correctly fit and mount a tapered bore spherical roller bearing. This is the mounting plate that we're using, and on it there is the stub shaft that we're looking at. You can see the threaded section where the nut goes on, and the tapered shaft where the tapered bore bearing fits on. And this is the bearing that we're looking at now. Here you can clearly see the shape of the spherical rollers. There's two rows within the bearing. You can also see the lock nut on the outside. That's the outer race. We're just pivoting around. You've got the inner race of rollers. And we've got the outer race. We've got the elements or the rollers in the middle, and then we've got the tapered inner race sitting on the stub shaft. That's the slotted lock nut that we're just undoing, screwing off now. Behind that is a small spacer that pushes the bearing onto the shaft. Checking the internal bore of the bearing is important to get the correct size, but we'll do that a little later when we come to fit the bearing. Tools that we require: just a hammer, a set of feeler gauges. The feeler gauges need to have blades on them going up in 100mm increments. A hook spanner or C-spanner there. There's a hydraulic releasing tool, an oil can, and verniers. Vernier caliper set. First thing we're going to do is fit this bearing using what method is termed the reduction in radial clearance. The first thing we need to know is what clearance is in the bearing. The first thing we need to know is the bore or the diameter of the bearing. We're just checking that with the verniers. The bearing checks out at 55mm. So if we go down the table or the chart here, the nominal bore, we can see that inside the 50 to 65, so we would sit inside that. The radial clearance prior to mounting on that size of bearing should be 5.5 hundredths to 7.5 hundredths clearance. So to check out what we have, we're going to hold the outer race of the bearing, hold it nice and square or perpendicular. That'll make sure you've got check the clearance at the very bottom roller. Probably putting in a 5/100ths feeler gauge there and slowly moving up, and 6 and so on, to see what the maximum is that we can get into that gap between the bottom roller and the outer race. It's important too that the whole feeler gauge blade fit right under the full width or length of the roller. It's not just the tip of the feeler gauge entering into the corner by 5mm or 10mm. It's got to go right in, so you're probably looking at 20-30mm of feeler gauge blade going right underneath or passing right underneath the roller. So the set that I've got here would be going up in 5, 6, 7, 8, 9, right up to 0.1 of a millimeter or 10/100ths. And that's 800 is fitted right underneath that roller. So now to check for 9. According to the chart, 9 shouldn't enter there. And it doesn't. Just write down what you've got for future reference. Now we've got to screw up that lock nut until we move the bearing further along the taper, and in so doing it will reduce the clearance inside that bearing. Just putting the spacer on, putting the drive up nut on to the stub shaft, screw that in. Use the hook or C-spanner and a hammer and drive that up. And that the bearing has been moved further along the shaft. And the outer clearance is being reduced. Just going to check what clearance gap we have there now. It's probably reduced down by 3 or 4 hundredths. Then we need to check that against the chart to see if it falls within the specifications. If it does, we can leave it. If not, we may have to take it up a bit more. Here we just have a look at the chart. We'll move across there, column reduction in radial clearance. And it should be a minimum of 3 hundredths and maximum of 4. So if I had 8 and we take away 4, the maximum, a 4 hundredths feeler gauge should just enter and a 5 shouldn't. I've got a 4 going under there. Now we're just going to dismount the bearing, take the locking nut off. Notice that we're leaving the locking nut on the end of the shaft, because if we were removing a bearing that had been on a shaft on a heavy earth moving equipment for maybe 5 or more years, it will have settled onto the shaft and it would be very difficult to move. So the hydraulic pressure that we would use to force it off could cause the bearing to come off at some velocity, and if we're standing in the front of that shaft, it could injure us, of course. So keep the lock nut on the shaft, plenty of clearance between the lock nut and the bearing when it slides off the taper. Then we can remove the lock nut and remove the bearing. What we're doing here is just unscrew the screwed spindle section inside this hydraulic release tool. Prime it up with oil. There's a plunger in there, which you may have noticed. I put a pin down in there just to make sure that the piston was right down on the bottom, then primed it up with oil. Screw it into the threaded connection on the end of the shaft. There's a T-handle on this, and once I've got it in, just nip it up lightly with a spanner. Once it's been nipped up, we'll just wind the T-handle in. That'll force the oil through the center of the shaft and out through a hole underneath the bearing, and you can see the bearing just move forward. It ejects the bearing off the tapered shaft.